Okay, here's 4.3, number 33 from the homework problems, and here we would just want to, we have a function y equals 3x minus x cubed plus 5, and we want to find the relative extrema using the second derivative test. All right, so we want to verify these using the second derivative test. So first of all, we have to take the first derivative to find our candidates for our relative extrema. So the first derivative, that would be just 3 minus 3x squared. Now that's not going to be undefined, but it will be equal to 0 when this is equal to 0, so I've set this equal to 0. I could just add that to both sides and then flip it, so I get 3x squared equals 3, divide by 3, so I get x equals plus or minus 1. So those are my critical points. And then I take the second derivative to see what that is, and that's just going to be simply negative 6x. And we just look to see where that's equal to 0. It's not undefined, but it's equal to 0, so and it's equal to 0 when x equals 0. So I draw both my first and my second derivative lines over here. And here's the first one with the critical points, negative 1 and 1, where the first derivative was 0. And this is where the second derivative is equal to 0. And I try some values in here. So I don't have to try the values in here like we did previously in some other problems. We just can put them right in here and do the second derivative. And if I put negative 1 in there, this is going to be the opposite, so that's going to be positive, because negative 6 times negative 1 is positive 6, so that's positive. And if I put 1 in there, that's going to be negative. So I definitely have a change of concavity here. I'm concave up from negative infinity to 0, and I'm concave down from 0 to y double prime. So if we want to find our points, we would have to put 1 and negative 1 into the original function. The original function was 3x minus x cubed plus 5, so I just put 1 in there. And I got 3 minus 1 plus 5, which is 8 minus 1 is 7. So 1 point is 1, 7. And then I can try negative 1. If I put negative 1 in there, I get 3 times negative 1 minus negative 1 cubed plus 5, which is all these negative signs, 3 plus 1, negative 3 plus 1, plus 5, which is negative 3 plus 6, which is 3. So these are my two points. So first one is over here. I've got 1. And at 1 I've got 7, so my point is 1, 7. And you can see here, since the value is 0, so it's a critical point. And since my second derivative is negative, that means it's going to be concave down. That means this is going to be a relative maximum. So I can say the point 1, 7 is a relative maximum because f of 1 equals 0. That means the slope here is 0. And f double prime of 1 is less than 0. So f double prime is negative, implies it's concave down, which implies that that's a maximum, relative maximum. And in the same respect, I can say that negative 1, 3 is a relative minimum because, again, f prime of negative 1 equals 0. And in this case, f double prime of negative 1 is greater than 0. So since it's positive, it's concave up. That means my change in my velocity is getting more positive. So it's concave up. That means it's down at the bottom of this little valley, so it's a relative minimum. And these are just your methods by using those second derivatives. All right? And we can look at number 35. 35 is a similar function. Again, we do the same thing as the same problems types there. And we take the derivative to find the first derivative, so we get 3x squared plus 6x. All right, this is again our original function, x cubed plus 3x squared minus 2. And is it equal to 0? Yes. Is it undefined? No. So we just set it equal to 0. So in this case, I factored out a 3x. So I got 3x times x plus 2. And then it's equal to 0 when x is 0 or when x is negative 2. So those are my two possible relative extrema. So I'll take the second derivative, and that's just going to be 6x plus 6. And again, that's equal to 0. We can set that equal to 0. It's not undefined, but it's equal to 0. Which is actually, it's a straight line. So I set it equal to 0. I get 6x equals negative 6, so x equals negative 1. So again, I draw both my first and second derivative lines. And these are my possible critical points when the first derivative was 0. And then I try I put -1, that's where my second derivative was equal to 0. I try, since it's -1, so I just try this into 6 plus, sorry, it's up here, let me get it up here so you can see that. So y double prime is 6x plus 6, so if I put a -2 in there, I get -12 plus 6, which is negative, and if I put 0 in there, I got positive 6, which is positive. So that's negative, that's positive, so I actually have a change of concavity because it's changing from negative to positive, my second derivative. So this is moving along real nicely, so we can just use these points. So I have to put -2 and 0 into my original function. Well, if I put -2 in the function, I get -2 cubed plus 3 times -2 squared minus 2. And then that's going to be -8. That's 4. 3 times 4 is 12 minus 2. So 8, -2 is -10. 12 minus 10 is 2. So I got -2, 2. And what goes with 0, if I put 0 in there, I just get -2. So those are my points. -2, 2, and 0, -2. And -2, 2 is a relative maximum. Here's -2, 2. It's a relative maximum. And x is -2. Why? Because f prime of -2 is 0. F prime of -2 is 0. And f double prime of -2 is negative. So since it's negative, I have a relative. Well, since it's negative, I'm concave down. So that's going to be up at the peak of this concave down. So that's going to put it up at the top of that little arc. Make it a relative maximum. And then this point 0, -2 is a relative minimum, because again f prime of 0 is 0, and f double prime of 0 is greater than or equal to 0. Or I'm sorry, greater than 0. F double prime of 0 is greater than 0, which means I'm concave up, which means that's going to be at the bottom of that, this will be relative minimum. Okay? So that's number 35. Okay?